equations are the official, like, mathematical term for, first of all, let me double check and make sure. Can you guys see my screen? Okay, just give me like a quick yes or no so I can make sure. So far, again, as long as I keep my camera off, I've been doing okay. But I just want to make sure. Can we see it?
Yes.
Okay, thank you. All right, so we started talking about, and started working some literal equations on Thursday. And literal equations is just the big kid word for equations with a crap load of variables in them. And we started by solving some fairly basic ones. Today we're going to do more big kid ones, but the process, the procedure is still exactly the same, okay? And I know you guys already have some notes with this written on it, but I'm just going to kind of write a little reminder up here at the top for what it is exactly that we are trying to accomplish. I very strongly encourage you to write that down as well before we start doing our first practice problem. So remember that our goal is to isolate the designated variable. So whatever variable it asks you to isolate, that's what you're doing. You are just trying to move the equation around to get the designated variable by itself. So in the case of number 1, we are trying to isolate x. So x is the one that we are trying to isolate. And the reason that we know that is because it says to solve this equation, and it says to solve it for x. So that means that x is the one that we want to eliminate. So the big idea, our goal, is to isolate that designated variable. How are we going to isolate that designated variable? Well, we're going to use two things, two big ideas. So we use inverse operations, exactly the same way that you do with just regular equations that have variables in them. So we're going to use inverse operations, and we're going to use properties of equality, the big kid word for what I do to one side. Oh, that should be plural, properties, sorry, of equality. So nothing new here, okay? Still the same big idea. The other thing that is still the same from Thursday that I know, especially smart kids like you hate, is that there's not necessarily one right way to do it. There are multiple ways to do literal equations. Like what makes sense to do it in a particular order for you might not make sense for me, but as long as you follow the basic rules of your inverse operations and properties of equality and you apply them correctly, you should still end up with the right thing regardless. So, number 1. So I'm showing you some examples today that are just like, I'm going to show you a couple of each type that are a little bit more advanced version of the ones. Actually, some of them aren't really all that advanced. They just look scary. Number 1 is a perfect example of that. So number 1 looks kind of scary, or at least kids tell me it looks scary. I'm going to recopy down here because I like having a little bit more room to explain my steps. So we've got the equation x over m is equal to p over n. And again, because I'm a visual person, I told you last week, I really like to highlight or somehow color what needs to stay put so that I have in my head, hey, I just need to move whatever is over on that side with the variable. Well, in this particular case, it looks like a hot mess because we've got a couple fractions and all of that, but there's really only one thing that is keeping that variable from being isolated because it's x divided by m. There's only one thing over there that is keeping it from being by itself. So even though it looks a little scary, it's really not as scary. But hey guys, Yeah, this isn't on class kick. I'm sorry. The class kick, we're going to be doing class kick practice in a few minutes. I'm sorry. I just got a text from one of you guys. I realized I didn't explain that. I didn't really explain that at all. When I said get your notebook, I didn't tell you it was because this is what you were doing it for. So here, I'm going to pause for a second. And I'm going to give y'all a minute in case, because that was my bad that I did not clarify that for you. So I'm going to give everybody a moment. If you need to go grab paper, I should have made that more clear that we weren't starting off on class kick. My fault. I really wanted you guys to write this part yourself, so I'll give you just a minute. All right, is there anybody that still needs a second? Have we had enough time with my bad directions to grab something to write on? Shoot me a little text on remind if you still need a second. If you don't want to speak up in the chat, I get that. All right, I'm going to assume that no news is good news. Okay, so back to, so I was trying to isolate the x. Well, I wasn't trying. I'm going to isolate the x. And the only thing that is keeping that x from being isolated is the fact that it is being divided by m. So we really only have one thing that we need to eliminate. We just have that m. So we are going to cancel out dividing by m. And we're going to cancel it out by multiplying by m. So those are going to cancel. Now you have that isolated x exactly like you need. So we have canceled dividing by m by multiplication. Our properties of equality say that if we multiply the left-hand side by m, we of course have to multiply the right-hand side by m. The only part that can be a little sticky in this case is that people might not necessarily know, like people typically know that they need to multiply the p and the m, but they're not really sure what they should do about the fact that that n is sitting there as well and whether or not you should multiply the m. So if you have a whole number, which this seems unrelated, but I promise it is, if you have a whole number like 2, the way you turn that into a fraction is 2 over 1, right? So when we're multiplying both sides by m, we're technically multiplying it by m over 1. We're not really writing it that way, but that's what we're technically doing. And when you multiply fractions together, you don't multiply, like you just multiply straight across. So you do like p times m, and then you would do n times 1. So in this case, the simplified version, so we've got our x isolated, so it'll just be p times m in the numerator, which the only way we can write it is just p times m because we don't know what p and m are equal to. And then n times 1 is just going to be an n. So remember, I always go back and double check and make sure that I have all the same variables that I started with. In the original problem, I had an x, an m, a p, and an n. I still have an x, an m, a p, and an n. They're just in a different order. So we've just rearranged that original equation, and now we have the x isolated exactly like we need it to. So even if it looks big and scary, all you need to keep in mind is what the heck is there with the variable that needs to be isolated, and what is the inverse I will use to get rid of it. So I'm going to pause for a second, check my remind, and make sure that we don't have any questions. We're good? Alrighty. Okay, so let's take a look at number 2. Number 2 is very, very similar to number 1. So I'm going to shut up for a moment and give you guys an opportunity to try that. And then I'll be right back with you. Okay, anybody need me to give them another second? Remember, you don't have to yell it out. You can just text me and tell me. Okay, I'm going to assume that means we're okay to go. So once again, we are trying to isolate the x because that is the one that they're telling us that we need to isolate. And the only thing that is keeping the x from being isolated, just like in the last example, is this division. So, because we're dividing by k, so the inverse of dividing by k will be multiplying by k. Over here on the left, that is going to cancel, leave you with an x. What you do to one side, you have to do to the other. Remember that you're just going to, I should be really worried probably that my kids are screaming up there, but I'm just going to ignore it for right now. Hopefully they're okay. So w times k is going to be wk over v times the one that's technically under there, but we don't really need to do anything with it. Just means that you're still going to have a v in the denominator. So big scary fractions, not really that scary, at least in situations like this one. Not too bad. I'm going to pause for a second. Are we good? Alrighty. So now, so the rules that we've added so far were the goal is to isolate the designated variable, and that we've got to use inverse operations and properties of equality. So what we need to do for this particular situation, well, we're going to have to do a couple of things, actually. So for starters, we need to write a big idea here. Let me find a pretty color. And that is an x, well, any variable, actually, I should change that to variable. Okay, because in this case, it's asking us to solve for x, which means that x needs to be isolated. So this one is goofy for a couple of different reasons, okay? The first thing that makes it goofy is that a variable, and you definitely need to write this down, a variable in the denominator. So right now, the variable we need is down here, right? Yes, I know there's another one as well. We're going to talk about that in a second. Right now, I'm just going to focus on the fact that that one is in the bottom, which doesn't happen very often. So the variable in the denominator can't be isolated. Because think about it. If you have a variable in the denominator, there's always going to be something on the top. So whether it's a 1, whether it's a bunch of other crap, it doesn't matter. But by definition, for it to be in the denominator, there has to be something above it in the numerator. So that means that it can't be isolated. It can't be by itself. So what does that mean for you? So actually, let me change how I'm saying that. we must get it out of the denominator. We still need to isolate it, okay? It's not that we don't still need to do that. It's just that until we get it out of that denominator, we're not going to be able to isolate it. So how on earth am I going to get that x out of the denominator? I'm going to rewrite everything. So that it's a little easier to see my steps. Well, if it's in the denominator, that means that the x is being divided. So how are we going to cancel out dividing the x? Hopefully we recognize by this point, we're going to cancel dividing by x by multiplying. So I'm going to multiply this side by x. So what'll happen over there on the right-hand side? This x and that x will, of course, cancel each other out. So we'll just be left with the x plus y. Don't worry, we're going to talk about what the heck we're going to do with this other x in just a momento. But, of course, what we do to one side, we have to do to the other side. So if we multiply the right-hand side by x, we got to multiply the left-hand side by x. And there's a few different ways that you could write that multiplication on the left. It basically just needs to amount to you writing all three variables just sitting next to each other, because that implies multiplication. Always does, always will. Sitting there right next to each other simply implies multiplication. So if you see the designated variable that you need to solve for in the denominator, I hate using the word always, because there's always going to be some weird exception that makes me a liar. But 99% of the time, if you see the variable you need in the denominator, you want to get it out of there. Notice I wasn't worried about getting anything out of the denominator for number 1, because it wasn't the designated variable that I needed, right? So that's the difference between the two. The fact that the designated variable that we actually need to isolate is here in the denominator, that's why we wanted to go ahead and attack that first. So this is one big idea, that the variable in the denominator needs to get out of there if it's the variable that needs to be isolated. And now here's our second new big idea. Because we've got two x's, right? We've got the x that's over here, and we have the x over there. So our next step, after we've gotten it out of the denominator, is that we need to move the designated variable. In this case, that's going to be x, to the same side. So what I mean by that is this x either needs to get moved over here to where that x is, or this x needs to go over there. It actually doesn't matter which one you do. As long as you do it correctly, you're going to get the same result. I personally feel like it makes a little bit more sense to go ahead and move the x over there, just because it's a little bit less work. Because if you move the x over here, you got to move all this other crap with it, because they're all together in one unit since they're all multiplied together. So how do I get rid of an x? I simply do a minus x, and I'm going to do that on both sides. So the x is now canceled. I'm going to bring down my y. What I did to one side, I have to do to the other. Now this is the part where it gets a little bit confusing, because this is all one term, an x, a z, and an m. That's all like one unit that goes together. That is not exactly the same thing as just a plain old x. Imagine, if you will, imagine an x is a cheeseburger, whereas XZM is like a Happy Meal with a cheeseburger. They've got some of the same stuff in there, but they're not exactly the same. They're related because they've both got an X in there, but they are not like terms because they don't have all the same variables. So that means that you cannot combine them. You can't like do an XCM minus an X. So when we rewrite this, we're going to have to leave them separated. So it'll be XZM minus X. So the first big idea, this one I know is doing a lot. That is why we're literally practicing today, and we are practicing in class on Thursday. So I know, please don't anybody panic. I know this feels like a lot. So if I subtracted, so my first big idea was that X needed to get out of the denominator. Can't be isolated if we don't get it out of there. We needed, so we can just cancel out that division by multiplying. And now the designated variable needs to be moved to the same side. So why are we moving them to the same side? That's because it's actually going to help us to isolate just a single X. We need to get just a single X out of all this. Right now we've got a whole bunch of crap over here that's like a big old mix. We got to get the X out of all of that. And we are going to do something that is probably a new concept to you. I would imagine you probably don't do this in 8th grade. So we are going to do what we call factoring. In parentheses, I'm going to call it, this is not a very mathematician way, but we're going to say unmultiply. And hopefully that'll make sense in a second. Unmultiply the X. So what I mean by that is I'm going to look and see where I have an X and I have an X right here. I'm going to literally like pull out that X out of both of those terms. So the X is going to come out. I'm going to literally like remove it from both of those. So what's left over after I remove the X? I still have the ZM and X. If I pull that X out of there, we still have a 1. So I'm going to prove to you that I can do that and actually get the same thing. You don't have to necessarily write down what I'm doing here, but I think it might help you. So I'm going to go back. So I just like pulled out that X, right? And a lot of people are like, well, how can you do that? Look what happens if I go back and I do the opposite. If I do distributive property. So right now I've got the X factored is what it's called. It's like unmultiplied, basically. I took that X, I pulled it out of that XZM minus X. So look what happens if I were to go back and just multiply it again. So X times ZM would just be XZM. And then X times -1 would just be a minus X. So I'm doing the opposite of distributive property. Instead of taking that outside X and multiplying it by both of the terms inside, I'm doing the opposite. I took that X and I pulled it out of there. So this is the opposite of distributive or unmultiplying. The only time you have to do this step is if you have the same variable that you're trying to isolate in 2 separate terms. And I know that step right there is probably the one that's like confusing us the most, I would say, if I had to guess. So we've got to get any variables out of that denominator. We've got to move the designated variable over to one side. And then we've got to factor or like unmultiply. We're doing the opposite of distributive. Instead of taking the outside number and multiplying it, we're doing the opposite where we're taking that same number and we're pulling it out. We are doing what's called factoring. So my X, That was doing the most. X is finally almost by itself. Our very last step is that we still need to do one last step to isolate it. And so this X sitting next to the ZM minus 1 implies multiplication. So we are going to undo that multiplication by division. So we are going to divide by ZM minus 1. What we do to one side, we have to do to the other, of course. So finally, we have our X isolated. So X is equal to Y divided by ZM minus 1. I know I keep repeating myself because people always freak out. I know this was doing a lot. I know this one was. And again, that's why we're going to spend a lot of time practicing. I do mean a lot. Okay? I'm going to pause here for a second. Wait for anybody that still needs, again, I hate it that we're like not in class together, so I can't see like who's still needs a minute. So I'm going to pause for a minute. This would normally be the time where I'd be like, who's got questions? And I'll bet you've got questions. So I just want to stop and make sure here for a minute that we've got this down so that we have an example to go by before we start. When it really clicks, it's just like how you guys were like at first the other day, oh, this is so confusing. And then you all aced your homework. There's literally like nothing we even need to go over from that homework. I promise this is going to be the same way once we get into the nitty-gritty and you start practicing. I promise it will. Does anybody need me to wait a second before we go to another one that I want you guys to try? Checking my phone. I don't see anybody asking about this one or telling me to wait. Alrighty, so I'm going to go to number 4. Oh, no, yeah, let's go ahead and, yeah, we will do number 4. So you guys try number 4. If you miss it, who cares, right? The world's not going to fall down. I'm not going to beat you up. You are not going to fail. Think about what you have written down on your paper. So think about these extra steps that we just added, and let's see if any of these steps apply. Is there a variable in the denominator? Do you have more than one of the designated variable that needs to be moved over to the same side? What's happening here? What do you need to do to get that X by itself? And I'm going to shut up. Even if you completely mess it up, that is okay. It literally doesn't matter because we're going to fix it and you're going to get smarter because of it. So I'm going to shut up for just a second. Okay. Anybody need me to give you another second to think? Okay, so our first big idea is still that we've got to get the designated variable isolated. So we need to get that one by itself. So now we're going to have to look at big idea number 2 that we just learned about, or our new big idea, which is that variable, the designated variable, is in the denominator. You can't get a variable isolated if it's in the denominator because there's always going to be something on top of it. So the first thing we're going to have to do is cancel out that division, and we're going to have to do it with multiplication. So that's going to cancel. I am going to have that isolated C left over there. What you do to one side, you have to do to the other side. So that's going to leave you with an X. So on this side at this point, what I have is a D times X all divided by R. So now we've got our variable that we need to isolate sitting up here in the top. So now there's some actual things we can do with it. So for starters, we're going to want to get rid of dividing by R. And we're going to want to do that by multiplying by R. What I do to one side, I have to do to the other side. So that's going to leave me with RC is equal to DX. And last but not least, we need to cancel out that D. And we're going to cancel out that D because it is multiplication. We're going to do that by dividing. So we finally have the X isolated. Took long enough. And we have R times C over D. Okay, I want to stop here as far as giving you examples. And this is where I want you guys to turn to the class kick, because this is where you're gonna really learn how to do it, is by trying to practice it yourself. I am gonna put you guys into breakout rooms because I really think it's important that you have some people to bounce some ideas off of while you are working on these problems. So the reason this is called a progression grade, it's classwork, is because you are not an expert at this yet, okay? Some of you guys might be darn right confused right now. What makes it click is when you really get in there and practice it, and yes, sometimes mess it up on your own. This is the number one issue that kids have in this unit, which is why we're devoting a lot of time to it. So, I'm going to make sure we all know, I'll actually share my screen with you again really quick to make sure we all know where we're going, just in case you haven't gotten there yet. Hopefully you have, because class kick sometimes takes a minute. So remember that I can see what you're doing while you're doing it, and while you're talking to your group. So right here, see how it says Monday, Thursday classwork? No way you're going to get this all done today. And I'm not going to expect you to work on this today or after today without me and without a group to support you. Okay? So I'll be able to see what you're doing while you're doing it. I'll be leaving you little comments, little notes. This one is not self-checking because it's kind of hard to make this self-checking since there's more than one way to do it, kind of, and if you type it in wrong, it might count it as wrong. So it's really important today that while you're working on it, that you are uploading. Believe me, I know that if you don't have a touch screen, it can be a little obnoxious to try to type on there. But remember, or to write on there. But remember, you have other options. You can add text boxes to show what you're adding and subtracting on both sides. You can upload a picture of your work right as you're doing it, problem by problem, because you're probably going to maybe I'm wrong, maybe I am. You're probably going to make a lot of mistakes today. and I need to be able to see what you're doing while you're doing it. So whether it's using the touch screen, if it's sloppy, I don't care. Okay, so whether it's using the touch screen, whether it is uploading a picture of each problem as you do it, I really need to see what you're doing while you're working on it. So until we get back to real life, unfortunately, this is the best we're going to get. So, whatever it is that you need to do to show your work a problem at a time, I just don't want you getting to like number 10 and realizing that you're not doing them correctly. So please, somehow, some way, give me your work in between each problem. So I'm finally gonna shut up. You literally don't have to listen to me talk for the rest of, well, unless you ask me a question, for today or the entire next class period, because the whole next class period will be you guys working on this and practicing on this together. So what questions do you guys have before I divvy you up into breakout groups? And remember, you can always come back here to the big meeting, and you can ask me a question on Remind, or even write a question on your paper, because I'll see it while you're working on it. But what questions do we have for the group before I turn you guys loose to be in your own rooms? Even though I am here if you need me. We're good? Okay.